All right, so we're going to take a look at problem number 5 in the looking back from thinking with mathematical models. In the next table, we have the relationship between the number of train trips and profit at a train station snack bar over 10 days. So we have day 1, 2, 3, 4, 5, 6, all the way to 10. We have the number of trains and the snack bar. Make a scatter plot using a number of trains and snack bar data. All right, so let's see. So the largest number is 20. Oh man, I only have 15 squares. I should have made 20 squares. Oh well. So essentially, I'm stuck counting by twos. So that's going to make this going to be 0, 1, sorry, 2, 4, 6, 8. And I'm trying to draw with a mouse pad, so if my handwriting gets bad, I am sorry about that. There's 12, 14, 16, 18, 20. And I will just be sad that I can't use the rest of it. And so clearly this means that we have the number of trains down here. And I don't need something that big. So we have the number of trains. Scroll down a little bit. All right. Which means that the snack bar profit has to be on this side over here. Profit. All right. So then the next thing is, we're going to start with 0 profit, right? And then we're going to look at the data, and the most profit we got was $100 or $190. So we need to get up to about 200. So I'm going to go with 20, 40, 60, 80. And again, really bummed that I didn't make a 20 column graph. Hopefully you don't have that problem. You just have graph paper and you can just count by ones, and here you probably count by tens. That's probably a better strategy than what I have going on here. So this is going to be 140. So 20, 40, 60, 80. Ooh, 100, that should have been 120. I am sorry. And that makes this 160. You probably noticed that before I made that mistake. And now you really can't read it, so I'm just going to redo it. So 100, 120, 46, 160, 80, here's 200. And it asks you to make a scatter plot of this data. Okay, so at 5 trains, so that's between 4 and 6. So 5 trains, we had a profit of 40 bucks. Then we had 8 trains and we had 85. Then we had 6 trains and we had 55. So here's 60, so 55 is going to be right about here. 12 trains and 110. It's going to be right about here. 15 trains and 165. It's probably right about 15, yep. Then we have 6 trains. We had a bad day. 6 trains and $65. Oh, that was better than the day before. The other day was 6 trains, so I guess we can't complain. Then 20 trains, big day, profit of almost $200, 190. 12 trains and 125. 14 trains and 130, a little bit higher, then 12 trains and 125 again. Okay, I don't need to put a second dot there. So this data clearly denotes a linear relationship. Is it exactly linear? No, but it is really close. So I'm going to go ahead and make a line of best fit. So going through the data points, and That looks pretty good, pretty good. And the reason why I like this line of best fit is, we're starting at 0, which is an easy number to deal with, and I have a bunch of grid points that I can use, which makes my life much, much easier. So then make a scatter plot, and then ask us if the correlation coefficient is going to be closer to -1, -0.5, 0.5, or 1. This is definitely closer to 1. These dots are really, really close to the line. So clearly, because our data is very close to the line, this is a very strong correlation and good line of best fit. Incidentally, the equation for this line of best fit, well, I'm going over 2 up 20. So 20 divided by 2 would be 10. So for every train that comes, you would expect to sell or to get a profit of $10 extra. All right, I'm going to get rid of that. All right, finally, of course, I'm obsessively erasing everything. The park operators asked visitors which parts of the park needed improvement. They recorded their suggestions on this two-way table. Love it. Farm, playground, picnic area, and based on the kids and adults. All right, so do kids and adults have different opinions on what areas should be improved? Well, it's hard for me to tell that until I find the percents of each response. So, I'm going to figure out here, we have 48 plus 24 plus 8, so there are a total of 80 kids in that same span. We have 45, we have 50 adults. Clearly, some adults have more than one kid. So, I'm going to pull this calculator up. And so if we had 48 divided by 80 for the farm, that's 60% responded farm. Well, let's see what the adults have to say. So if we go 30 divided by 50, we get 60%. So kids and adults are definitely in agreement on this one. Let's take a look at the playground. So 24 divided by 80, 30%. 15 divided by 50. At this point, it's safe to say that adults and kids have the same basic ideas on what needs to be improved. All right, so use the data to support the answer. Well, based on the data, 60% said the farm needed to be updated for both the kids and adults, 30% for the playground, both kids and adults, and then the leftover is going to be, 10% is going to be the picnic area, kids and adults. Suppose someone claimed kids value the farm more than adults do. What would you say the claim? I'm not sure I'd agree with that. It's at 3 o'clock. The reason why they're saying that is there are 48 kids and only 30 adults. But percentage-wise, it's the same. So that's what the error is. They're just wrong. Suppose someone claimed that kids value the playground more than adults do. What would you say about that claim? Again, no. Because just because there are more kids doesn't mean the percentage is different. All right, that's all we got. So I hope that helps, and I'll see you in class.